Hello, I'm Chris Wright. Today I present Rotex Technology's new podcast episode, Technology Will Reshape Future Engineering and Manufacturing Sectors. 1. Introduction. The advent of AI, artificial intelligence technology, has ushered in a new era of transformation across engineering and manufacturing sectors, from research and development to design, manufacturing, and aftermarket services. This transformative technology is reshaping how industries approach product design, production, and maintenance, leading to increased efficiency, improved quality, and enhanced customer experiences. AI is poised to revolutionize the entire lifecycle due to its ability to process vast amounts of data, identify patterns, and make predictions with unprecedented accuracy. In the realm of engineered industrial products, the impact of AI is profound. 2. AI techniques driving changes. At the heart of this industrial metamorphosis lie three core AI technologies around data: A. Machine learning (ML), the ability of systems to learn and improve from experience without explicit programming. B. Deep learning (DL), a subset of ML that uses neural networks with multiple layers to analyze various factors of data. C. Artificial neural networks (AN), computing systems inspired by biological neural networks, capable of learning complex patterns. These technologies form the backbone of AI applications that are transforming the industrial engineering and manufacturing. 3. Engineering, design and R&D. AI's role in R&D is perhaps the most inventive. Traditional R&D processes are often time-consuming and resource-intensive, involving extensive experimentation and trial and error. Generative design powered by AI is changing the traditional design paradigm. AI can significantly accelerate this process by leveraging machine learning algorithms to analyze historical data, simulate experiments, and predict outcomes. Machine learning algorithms can analyze vast amounts of performance data to optimize product designs. By considering factors such as material properties, manufacturing constraints, and performance requirements, AI can suggest design modifications that improve product performance, reliability, and manufacturability. In mechanical engineering, for a part that needs to withstand high stress, the AI-generated design might have a complex lattice structure that is both lightweight and strong. This capability is particularly valuable in industries like aerospace and automotive, where the performance of materials under extreme conditions is critical. These designs are often optimized for the specific conditions and are difficult to conceive through traditional design methods. AI is dramatically accelerating the R&D process for industrial products, enabling faster innovation and more efficient use of resources. AI-driven data analytics can process vast amounts of existing research data, market trends, and customer feedback at speeds far beyond human capability, accelerating R&D design cycles. This enables companies to identify gaps in the market and potential areas for innovation more quickly. For example, in the automotive industry, AI can analyze data from various sources such as traffic patterns, consumer preferences for vehicle features, and emerging safety regulations. Based on this analysis, R&D teams can focus on developing new technologies like advanced driver assistance systems (ADAS) or energy-efficient drivetrain. AI-enhanced simulation and numerical modeling tools are recasting the R&D process. With machine learning algorithms, these simulations can become more accurate and detailed. In aerospace engineering, for instance, AI can be used to simulate the complex aerodynamics of new aircraft designs. By adjusting various parameters in the simulation, engineers can optimize the design for better performance, fuel efficiency, and safety based on what-if scenarios. This reduces the need for expensive and time-consuming physical prototypes and test flights during the early stages of R&D. AI-enhanced virtual prototyping and testing tools allow designers to simulate product performance under various conditions without the need for physical prototypes. This capability reduces development time and costs while enabling more thorough testing and validation of designs before moving to production. It will soon be new norm of NPI new product introduction process to accelerate new product launching in the market. 4. Manufacturing. AI's impact on manufacturing is equally profound. Smart factories equipped with AI-driven systems can optimize production processes, reduce downtime, and improve overall efficiency. Predictive maintenance, for instance, uses AI to monitor equipment performance and predict when maintenance is needed, preventing costly breakdowns and ensuring continuous operation. AI can also enhance quality control by using machine vision to inspect products for defects. This automated inspection process is not only faster but also more accurate than manual inspections, ensuring higher product quality. For example, AI-powered visual inspection systems are being used in automotive manufacturing to detect minute flaws in paint finishes and body panels. Additionally, AI can optimize supply chain management by predicting demand and adjusting production schedules accordingly, reducing waste and improving inventory management. AI-enabled manufacturing systems can adapt to changes in production requirements quickly. For example, in a custom-made furniture manufacturing facility, AI can adjust the production process based on the specific design of each piece of furniture. It can control robotic arms to cut, assemble, and finish the furniture according to the unique dimensions and styles specified by the customer, enabling efficient production of customized products. 5. Aftermarket services. AI is transforming aftermarket services, enabling more proactive and personalized support for industrial products. AI-powered remote monitoring systems allow manufacturers to keep track of the performance of their products even after they have been sold. In the energy industry, for example, wind turbines can be equipped with sensors that send data to a central server. AI algorithms analyze this data to detect any signs of malfunction or performance degradation. This enables timely intervention, reducing downtime and maximizing the energy output of the turbines. Chatbots and virtual assistants driven by AI can provide customers with quick and accurate support. When a customer has an issue with an industrial product, they can interact with the chatbot, which can diagnose the problem based on the symptoms described. The chatbot can then provide step-by-step instructions for troubleshooting or arrange for a service technician if necessary. This improves customer satisfaction and reduces the time and cost associated with resolving customer issues. AI can analyze the performance data of existing industrial products to recommend upgrades or retrofits. In the case of industrial machinery, if the analysis shows that a particular component is becoming obsolete or underperforming, the manufacturer can offer an upgrade option to the customer. This could involve replacing a mechanical part with a more advanced one or installing new software to improve the functionality of the product, thereby extending its useful life. 6. Case studies. Several industries have already begun to implement AI in their operations, with notable successes. In the automotive industry, companies like Tesla and BMW are using AI to optimize their manufacturing processes and improve the design of their vehicles. AI-driven simulations help these companies test new designs and materials, reducing the need for physical prototypes and accelerating the development process. In the aerospace industry, companies like Boeing and Airbus are using AI to enhance the design and manufacturing of aircraft. AI-powered generative design tools help engineers explore new design possibilities, leading to more efficient and lighter aircraft. Predictive maintenance systems ensure that aircraft remain in service longer, reducing downtime and improving operational efficiency. 7. Conclusions. As AI technologies continue to evolve, we can expect to see even more profound impacts on industrial engineering and manufacturing sector. Future developments may include more autonomous decision-making in design and manufacturing, increased integration of AI with Internet of Things technologies, digital twin, and the emergence of entirely new product categories enabled by AI capabilities. However, realizing the full potential of AI in the industrial sector will require addressing challenges related to data security, workforce and skill development, and ethical considerations. By doing so, companies can harness the power of AI to drive innovation, improve efficiency, and create more sustainable and resilient industrial products. The future of engineered industrial products is undoubtedly merged with the advancements in AI. The companies that embrace this technology will be at the forefront of the next industrial revolution. Please visit our website www.rotextechnologies.com to learn more. Thanks for listening.